Okay, this is lead code 3977. Minimum time to reach target with limited power. We're given a directed weighted graph with endnodes labeled from 0 to n minus 1. And the graph is, we have edges, okay. It's weighted by time. Takes t of I, okay. And we're also given an integer power, representing the initial available power, and an integer array cost of length n, where cost of u represents the power. So it's only when we leave u, we consume this power. You are also given two integers, source and target. Okay, the signal starts at source at time 0 with power units, and signal may traverse the directed edge from node u only if the remaining power is at least cost u. Power is consumed when the signal arrives at a node. Unless it later... No powers, okay. Okay, so that's the only when we leave bit. When the signal is forwarded from u, the remaining power is decreased by cost of u units. Traveling an edge, edge is I, is equal to u of I, v of I, t of I, t of I seconds. Return an integer array answer of time. So we want the min time required for the signal to reach target with the limited power, but we also want the maximum remaining power among all paths. So even if it's like the slowest, we want the maximum remaining power. Why? Okay, so this is a single source shortest path problem, so this kind of implies a Dijkstras solution, but there's this added dimension with the power. So maybe we run Dijkstra on a DP. It's a 2D DP. DP I J denotes the min time to reach DP of vertex I with J power, maybe. Thing is, so like, do we want exact? Can we do like cumulative power? Like at least J power? Maybe. That seems really annoying though. I mean, let's try to do a sample of this. If we want to start 0 and go to 4, and we have 4 power, we can go 1, 2, 3, and that uses up 2. Maximum remaining power among all answers that achieve. Oh, it's the most power we can have after. What? Oh, because of the cost, right? The cost isn't shown here. Okay. Okay, so like, hypothetically, let's say we have this, then at n we just do a linear search on dp of target, right? And dp of target, we can say like res of 0 is equal to like min dp of target, and then I don't know, iterate right to left and pick first j such that dp of I j is equal to min dp of target. Maybe. Okay. Oh, we'll figure it out. It is long. Just anything about. I mean, because this is time, right? 0. What the hell? I mean, I assume it's if each time is 10 to the 9, and we have that. Okay, so I guess we're gonna do a long array. dp is equal to new dp. Let's do n vertices. It's numbered 0 to n, so it's great. Right? Yes. And we want to power. I guess for simplicity's sake, let's just write power plus 1. That way I don't have to, like, shift it. And let's construct our adjacency list. Right? New array list. And for int I equals 0, I, adjacency of I is equal to new array list. And cost source. Okay, I'll worry about that later. And for int edges, it's a directed graph, so honestly we don't need the line. Let's just say adjacency of edge 0, add int edge of 1, edge of 2. So we constructed our adjacency list. Now let's have a priority queue. Int, and for now let's have it to this. Alright, override. I really need to have like a copy and paste template for this at some point. A of 0, A of 1. Oh my god, minus B of 1. We should probably fill dp for int I equals 0 is less than n. Just I arrays.fill dp of I with integer.max value. And that denotes that it's unvisited. And okay, so let's say dp of source with we have this much power when we reach it. It's equal to 0. Right, and we want to get to target. Unfortunately, you can't just... Yeah, we'll figure it out. Okay, and we're gonna do pq.offer. Ooh, we do... Okay, so each time we queue a vertex into the heap, we want vertex current time spent, and then current power left. Right. So maybe we can override the time with maybe the power, maybe. I don't know. New int, we're gonna say source power, no, power 0, power, and while pq dot is empty, we're gonna say int cur is equal to pq dot poll. We'll say, ooh, this should be a long though, shouldn't it? Which is really annoying because I know for a fact that the time is gonna like mess with me. Oh, and then now I have to compare longs. See, I don't leak code. Why? How do you compare longs in Java? Is there a long.compare AB? That's great. Long.compare A of 0, B 0. Right? So now this is a long. See, I found recently some of these problems I solve with shortest path. I'm doing it chill. Everything's chill until they give me the test case with 1,000 edges, and then all of them are weighted at 10 to the 9. So then there's overflow. Why? Why? I don't know. Okay. And let's say long u. And can I index? been a while. Index arrays using a long. I should, right? We cannot use long. Serious? Cool. Okay. Int u is equal to int curve 0 v, not v, u dub is equal to, hey, I'm going there, curve 1, and we'll say that p is equal to, oh wait, I can't do this as a long, right? P of int curve 1, 2, long dub is equal to curve 1, right? And we can do the visited check if dp of u at p is greater, I mean, if u dub is greater than this, then we can continue. Otherwise, for int edge in adjacency u, say int v is equal to, actually, no, we can also do this. Or the current power we have is greater than cost of u. We just stop, right? It's always when we leave. Cost of u. Okay, the remaining power is decreased by cost of u when we leave from u. So in theory, once we get to the place p vertex u and we have p power and p is less than the cost to leave, then we must cease. So in b is equal to, and I guess we could do p minus equal to cost of u. In v is equal to edge 0. Yeah, okay, that checks out. And w is equal to edge of 1, yada yada, if u dub plus dub is less than dp of v with this much power, then we're going to say dp of vp is equal to u dub plus dub pq dot offer int v dp of vp with p power, right? And then, okay. In theory, this does everything correctly. Long rest equals a new long 2, right? And let's do long mean is equal to integer dot max value for int I equals 0, I is less than or equal to power plus I. If I'm not writing if statement. We'll do min is equal to math dot min dp of target. Target is numbered, right? Yeah, okay. Target I, and then for, we'll say res of 0 is equal to min for int equal power. Power is greater than equal to 0. Minus power. If dp of target I is equal to min, say res of I is equal to I, return, let's do break, we can do a nice return statement here, return res. Watch it break, it's not going to even compile, is it? Fuck. Cannot find symbol, new dp. That makes sense, because this would be a new long array. Right? Okay. I can't spell. Priority. I'm offering ints when you should be long. Am I doing that anywhere else? Cool. Maybe, you know what, it probably will just be easier if I write if min is less than dp of that, then min is equal to dp of target I. Yeah. Okay. Anything else? Okay, so it's out of bounds. Power minus. That's not good. It should be I. Yeah. We are still out of bounds. And why is that? Index 4 out of bounds for length 2. Res of I should be res of 1. Okay, so it's just wrong. What the fuck? Okay, and it, yeah, that makes sense. 4, 2, in this case, power is 3, which is weird. That's weird. Okay, so it's not doing anything at all. For int I equals 0, I is less than n plus I, system out, erase 2 string dp of I. Let's print out the dp table. Let's see where we went wrong. Okay. So there's clearly a fuck. Am I slow? Wait. I don't know how to write a statement chat. Okay, that's a little more. Okay. And then if it doesn't exist, if okay, so if min, if min is equal to integer dot max value. Wait, because it's long though. You know, what are the odds that they make a test case where like one of the actual values is integer dot max value, right? That'd be ridiculous. Return new long -1, right? Okay. Now we're gonna. Where did I print? Why is this 1 millisecond? Am I printing anything? Output. This is already kind of slow with 1 millisecond, but we're gonna hope that I'm good at programming. Please pass. Time limit exceeded. Okay, so power is 280. Oh man, like what the hell do you want me to do? I mean, is there ever a case that target equals like or are you time limit exceeding? Am I? So we need this. I think because so n is less than or equal to 1,000 and power is 1,000, which means worst case we have like a 10 to the 9. Oh, that's a lot. A 10 to the 9 dp table. Would that be causing slowness issues though? I don't know. And this is the right idea. I mean, I guess we could change it to at least power, but Because if we can reach a vertex with, say, 9 power in like t time, but we reach it in t time with 12, then then I have to do like a linear search each time, but I guess that would mean I'd eliminate I don't want to do that. Okay, let's use this as a test case. Although the fact that it's stalling here is kind of an indicator. Unless the answer is part of it. Like, what if we had DP? Ooh, that's kind of rough though. How would that? If we had like a magical data structure that could that would give us the minimum time and the maximum power we could have given that time, that'd be great. And then we can like go through and check. I wonder if it's time limit exceeding because of the DP though. If we wrote hash map integer. Ooh, that's already really gross looking. Okay, well, how about this hash map integer to a integer pairs. That's so dumb though. Like dp of I hash map. And then we can do dp of source dot get power, no, dot put power 0. Okay. dp dot get dp of u dot get p. Okay. Less than dp of u get p, not u. Okay. If okay, so for integer p in for integer val in dp of target dot values, right? And values from Java hash map. Yeah, values. Min is greater than val. Min is equal to val. And if min is equal to integer, then I return that. It's a 0. Okay, so for integer key dp dot get kind of wish it was ordered. Key set. Is it dot get key set? Key set. Dot key set. dp of target dot key set. If dp of target dot get key is equal to min key is greater. I mean, honestly, this way res of 1 is equal to key. Is p an integer? Why are you unexpected? You shouldn't be unexpected. Found variable. What? I just used 0 right here. Oh, that put v p v dot sw. Okay. Long cannot be converted to integer. That makes a lot of sense because this would be a long, which means when I enter it cannot, man, fuck you. that better? If dp of v contains p dp of v dot put p integer dot max value. Contains key. L. Back. Okay. Long. This should probably just be long.max value, but you know what? It's fine. Oh, did that. But is it just what we time like see here? Is it just because it's running it all at the same time? Is that what's happening? Yeah, okay, so my algorithm works is just I'm doing it too slow. This one I think passed more. Okay, wait. So it's probably, I don't know, allocating an array with 10 to 9 elements. Okay, so we probably want to stick with this. Okay. It's the Dijkstras algorithm that I need to optimize better. 0. We want the bigger one of the power, right? Else, just do. Wait, how the fuck is that working? We're comparing the first element. It should be... Oh, God. Is that why? Why are we comparing the vertices? I swear to God, if this makes it like... Oh my God. Oh my God. Okay, we got a wrong answer. Okay, well now I'm curious, would this have worked if I just wrote it correctly? Like how many, this is 90 milliseconds. This is 60. Oh my God. Oh my God. So fucking dumb. Okay, long max value. Okay, that checks out. Let's just debug this a little better. Replace every instance with and let's use you. Oh god damn it. Oh, it's still really slow, and I think it is because of this, but I mean, I'll take a win when I can take a win. Oh, how did they do it? Time, power, node, okay. We have dist. Okay, wait, though, they use the same thing as me. Okay. Oh my god, okay. Okay, so we can kind of... Okay, wait. So if this equals 0, we can long.compare A2. You want the most power. 2. Else compare long.compare 1. 1. Alright, and this should still work. Okay. Okay. But then continue. I mean, if u is equal to target, we do a return new long -1, return new long dedup. Wait, let's copy. Okay, we did have a really similar. If A0 does not equal B0, return the time, otherwise compare the power. Okay. Okay, well, I'm curious. E dub plus dub is less than B. And P is minus equal cos U. Foreign edge and graph here. Hey, we write code pretty similar, huh? Probably learned the same thing I did. Elong D P. Oh, maybe like this. Okay. Okay, well then there you go. Do we need this even? Did he even fill? Okay, yeah, he did fill. Awesome. Okay, yeah, that makes sense. I was kind of considering if I want to do that, but I don't like thinking, so thank you, guy. I solved that relatively fast, I feel. Okay. Oh, that only took 40 minutes. Okay. Bye, guys.